Challenging time. The recreation of the dire wolf. Imagine a world where gigantic predators roamed under frozen skies, hunting alongside creatures we now know only from fossils. The dire wolf, one of the most fascinating beings of that era, is back at the center of scientific discussions. But are we really reviving extinct species, or are we creating something entirely new that never existed before? The dire wolves are not just shadows of the past. They were fierce carnivores that dominated the ecosystems of the Ice Age. With unique features such as a powerful muscular structure and distinct fur, they were top predators that coexisted with a diverse megafauna. However, the extinction that occurred about 12,500 years ago wiped these magnificent creatures from our planet. Now, scientists are attempting to take an unimaginable step, bringing these felines back to life through genetic engineering. In 2025, Colossal Biosciences revealed to the world 3 wolf pups: Romulus, Remus, and Kesi. These are not just ordinary wolves, but the embodiment of an ambitious project aimed at creating dire wolves using advanced genetic editing technology. However, this ingenious idea raises a fundamental question. Are we truly resurrecting an extinct species or creating something that merely resembles what once existed? To understand what is at stake, it is crucial to explore the challenges scientists face. With a genetic separation of 6 million years between dire wolves and gray wolves, Colossal Biosciences decided not to reconstruct a dire wolf from scratch. Instead, the team chose to perform edits on the genes of existing gray wolves. This involved 20 genetic modifications spread across 14 genes, aimed at expressing traits believed to have characterized dire wolves, such as a larger size and distinct fur coloration. When the pups, Romulus, Remus, and Kesi were born, the atmosphere in the laboratory was a blend of electrifying excitement and uncertainty. While the team was aware that they had achieved something remarkable, the question lingered over them. Are these pups really dire wolves? This inquiry fueled a heated debate within the scientific community. The creation of these pups sparked profound discussions about the definition of species. With 99.5% of their DNA shared with gray wolves, many experts argue that what has been created is not a true dire wolf. Some scientists, like geneticist Pontus Skoglund, firmly maintain that this creation should not be considered the first true de-extinction. For him, this is simply a gray wolf that has been transgenically modified to resemble a dire wolf. This perspective underscores the scientific complexity and limitations of such projects, reinforcing the idea that millions of years of evolution cannot be overlooked through simple genetic edits. The question of what defines a species, its DNA or its legacy, sits at the heart of the debate. The scientific community is divided into 2 factions: those who emphasize genetics and those who believe that a species' identity should include its evolutionary history and its role in the ecosystem. What is at stake here is much more than science. We are grappling with the ethics of genetic determination and what it truly means to exist as a species. But there is an even more critical aspect to consider: the nature of the world into which these dire wolves would be reintegrated. The landscape that once harbored these predators is now unrecognizable, compromised by environmental destruction and the extinction of their prey. If we were to bring dire wolves back to life, they would exist in an already fragile ecosystem, lacking the conditions that ensured the survival of their ancestors. The story of dire wolves also offers valuable lessons for modern conservation. Instead of attempting to recreate extinct predators, shouldn't we focus our efforts on protecting and preserving the species that still exist and are threatened? What we can learn from the fate of the dire wolves may help us safeguard the last remnants of endangered flora and fauna. The pups, Romulus, Remus, and Kesi, represent remarkable innovations in biotechnology. However, they are fundamentally different from their ancestors. This experiment not only reveals what we can do with modern science, but also prompts reflection on responsibility. It is our choice. By breathing new life into genetic modification projects, could we not use this knowledge to ensure a beneficial outcome for the species that still inhabit our planet? If you feel as intrigued as we do about the future of science and the preservation of biodiversity, subscribe to the channel. Share your thoughts and tell us, should we seek to resurrect extinct species, or should we dedicate ourselves to saving those we still have? Until next time,